Speed to market is a common driver in manufacturing and life science projects. It requires some facilities to be completed before the product and/or manufacturing process have been defined. Facilities sometimes need reconfiguration for multiple uses during their operational lives. This research identifies various innovative methods that can contribute toward the development of a flexible facility early in the design process. Here to share with you their findings, please welcome Evan Steinberger, Gul Okudan Kramer, Rob Brown, Todd Duckworth.
Good morning. Everybody used the word excited yesterday, so we're thrilled to be here to talk about facility flexibility. Just a quick show of hands. How many owners in the room? How many builders in the room? How many engineers in the room, building engineers? How many architects in the room? Am I the only? Oh, good, more than one, thank God. Good. Okay. So you all probably have a different feeling or interpretation of what facility flexibility really means. We're here to give you some tools to help you define it early and use it to your advantage. There's a lot of information in this presentation. We use the word dense, but there's a lot of information. So don't worry about the details so much, but please try to extract some concepts, put some ideas in your head, and then we'd be glad to get into the nuts and bolts later, okay? So here we go. Good morning and welcome to our Manufacturing and Life Sciences Sector Facility Research Team presentation. My name's Evan Steinberger. I work for Jacobs in the Life Sciences sector. I'm an architect that's focused on feasibility studies and concept designs. I know how messy it can be to try to develop a facility design, particularly one that's got facility flexibility in mind. I joined this team to look for a more objective, fact-driven approach to that process, and I'm thrilled to discuss our progress toward that goal. Recognizing this problem, our research team came together to answer an essential question posed by the manufacturing and life sciences sector. How can we create a method for developing a flexible, long-lead facility with an evolving manufacturing process and uncertain market demand? As a result of this effort, we can help you better position your facilities and company for the future. But what does this mean for you? Experience shows that design teams can fall in love with a design and then back into reasons to support the idea. But when the team is asked by their supervisors, well, you have to justify your approach, subjective reasoning often falls short. We believe a more appropriate approach would be a fact-driven, based on due diligence up front, to provide objective analysis to support your conclusions. In addition, by using our research tools, we're confident that products can be brought to market faster and that capital facility costs can be better optimized over their operational life. Why are these benefits so important, and why should you care? Take a moment to look at these stats. Uncertainty is incredibly common in the manufacturing and life sciences sector. This uncertainty creates several challenges for developing capital facilities. First, consider that manufacturing companies and their products are in part driven by competition. How fast they deliver or speed to market becomes more important every day. This drives many companies to launch facility design and construction projects before the product or process is fully defined. Add in schedule compression, and you have substantial risk, both financial and technical. Next, as these risks stack up, they make it much less likely that your facility can be delivered cost effectively. We look for better ways to understand and control the project. Flexibility is one of those tools. You might think adding flexibility will add risk. Well, we're here to discuss the opposite. With a toolkit that leverages flexibility, you can have more control during the development process. There are three main points we want to emphasize from our research. The future of manufacturing, we believe, is flexibility that gets products to market as quickly as possible. Our current approach to facility design and development is lagging, and we need to catch up. Second, we need more objective, fact-driven decision support tools. Flexibility is an investment, and we should be striving to optimize that investment early. And the best way of addressing the uncertainty in our sector is to move beyond the idea of a dedicated facility. We can no longer plan on a facility making just one product for the next 20 years. We need more options, more flexibility. To approach this research, we assembled a diverse research team composed of owners, architects, contractors, industrial engineers, and consultants. We conducted a rich set of case studies across a number of facility types. Our research team visited many of the plants and talked directly with the decision makers. We also performed surveys of CII companies in the manufacturing and life sciences sector. Across these data sources, we found consistency that has driven our results. So let's get started. Our approach and the tools we developed to support it are built around three key stages of any design process. Select a strategy, understand then optimize the cost range, and to keep the team moving forward, a means to resolve in-process design challenges. When are these tools applied? Experience tells us that flexibility is not an add-on. It's not something to be factored in or layered over a design. It should be part of the design from the feasibility phase moving forward. In each of these stages, our team has developed a tool or resource, part of what we're calling the Manufacturing Facility Flexibility Decision Support Suite. Everybody please say that 5 times fast. Strategy Selection Guide, which uses decision-making workshop to identify the best facility design strategy. A Cost Evaluator, which helps us understand and optimize facility costs based on familiar uniformat categories. And the Flexibility Idea Generator, which rationalizes design concepts through structured brainstorming. Now, to illustrate how these tools can help your team make decisions during the front end of a facility development process, we have prepared a case example. In this case, we wanted to build a new biotech facility that has a need for flexibility. But first, please turn your eyes to the following video. Let's see how our research can help with the process.
Problems with uncertainty occur early during the feasibility phase. Recognizing this, our facility must consider flexibility early. For example, we are preparing to build a new biotech facility to launch a new product. This product has a wide range of demand projections, anywhere from 1,000 units per day up to 25,000 units per day after 5 years. Each of these projections suggests a different strategy to approaching facility design. We could build a very large facility, a mid-sized facility, or even several small facilities. Reaching an agreement on our strategy for this biotech facility seemed like an impossible task. There is definitely a risk of overbuilding if the demand doesn't materialize, but we don't want to get caught without having adequate production capacity if the high-end projections came true. We can lose significant sales if our facility can't meet the actual demand. Using the design selection tool, we decided on a general-purpose facility that could allow for the rapid addition of equipment without disrupting our current operations. This gave us the best ability to balance short and long-term demand. How did we come to this decision?
Good morning. My name is Todd Duckworth. I'm a design lead in the Global Facility Delivery group for Eli Lilly and Company. As an owner responsible for designing and delivering facilities, we're seeing an increased need to deliver facilities much quicker than ever before. On top of that, it's becoming more common that we're having to do that when the process is still under development, and a lot of times with capacity demand scenarios still in play, multiple capacity demand scenarios. This has proven to have been a very difficult and painful process. And end result is too many times when a facility doesn't meet the needs of future capacity or can be done so only at significant capital costs. So I'm really excited to be part of this research team. I think the tools and research we're presenting today can help bring balance to what often is a very emotional process, or a process that is focused too much on just the initial lowest capital cost option. As part of the research team, based on statistical analysis, we determined there were three primary types of facility designs. The first is the dedicated facility, which is more the traditional approach. These type facilities are optimized around a specific product or process and a specific demand. So they're single purpose, more or less built for that. The other two options are the scalable facility and the general purpose facility. A scalable facility, as you can see, starts as a small facility, but can effectively increase in volume by replicating a design. So this can work very well if you have an unknown initial capacity. You want to build a facility to meet that demand, but then need to respond rapidly because you can just replicate the initial design that you had, just make more and more modules. The final one is a general purpose facility, and this is more of an open process building or a shell. It gives you a lot of flexibility because you can reconfigure the process within the building, or you can add additional equipment to add additional capacity as needed. The first tool we'd like to present to you today is a strategy selection guide, and it functions as a decision-making workshop. It brings the user through a series of processes, select the best facility based on unique facility requirements and uncertainty that they're being challenged with. The guide is a two-part process. The first step is to enter a rough order of magnitude estimate for each of the facility types, and this can either be done on a cost per square foot basis or just the overall facility cost. The next step is to use a choosing by advantages style workshop where flexibility is considered advantageous. Within this workshop, the user will compare various degrees of flexibility and assigns a important rating to each. The choosing by advantages method is a much more rigorous approach than a pros and cons discussion, and it's a proven technique for this type of analysis. The workshop will guide the team through various advantages that have different facility strategies that could be used to deal with the uncertainty, and the importance of each of these are then entered into the worksheet with the numerical value. This process is then repeated for each of the different facility strategy options that are available. So as an example here, we've shown just one of those from the worksheet, and this is, if we go back to the biotech facility that Evan mentioned that we want to build, that example, there's a great amount of uncertainty and demand for this facility. There's a steep potential demand curve in the next 2 years, and long term, there's also some uncertainty associated with that. So to fill out this chart, we looked at the options here and looked at the different advantages, and a facility that can rapidly expand in the short term was our highest priority. We don't want to be left short in the next 2 years if the demand does go up at the steep curve as it could. So in this case, we added a value of 100 for that as our most important strategy. There's also uncertainty long term about what the demand may be, so it's still important to us, but not quite as important, so we entered a value of 75 for that option. The last option in this box was the set capacity. That really didn't play out for this scenario because we really don't have a set capacity to design around, so we entered that value as a 0. This is then repeated for all the different facility strategies and selection options for the other ones. We're just showing one example here today. Next, the sum of advantages scores for each facility strategy are compared against the estimated cost, and predefined selection rules are used to help you optimize which facility design you should continue with. The output of the workshop provides a graph showing the importance versus the cost for each of the flexible facility strategies. Then to determine the optimum strategy, you would compare the line between the different strategies with the value line. Now the value line here is shown as the yellow dashed line. That's a line that represents what incremental capital you'd be willing to spend to gain additional flexibility. The tool comes preloaded with the value line, but it can be adjusted as needed to meet your own company's needs in that category. So in this case, you would compare the slope of those two lines, and if the slope of the facility from one facility to the next is less than the value line, then you would go to the facility on the left. And that's because in that case, you're not getting the value for that extra capital in terms of provided flexibility. If, on the other hand, the slope is greater than the value line, like this next slide, then you pick the facility to the right. And again, you would do this because you're getting incrementally more flexibility. The value of that flexibility is worth more than the capital that you spend for that. For the case of the new biotech facility example we've been talking about, the team went through and entered all the information for that facility into the tool, and this is an actual output from the tool so that you can see how that works. And in this case, it came back with the general purpose facility would be the best selection for our uncertainty. And you can see that because the slope from the scalable to general purpose is greater than the value line, but going from general purpose to dedicated is less than the value line. Once we've decided on a general purpose facility, then we can start working on the configuration to see how that would allow for future equipment expansion without changing the facility. So in this case, you can see we designed the facility for not only the 2 harvesters that are kind of shown highlighted there in the blue square, but also four additional ones that can be added in the future. This approach allows us to very rapidly expand the capacity of the facility because we've already pre-planned in the facility and in utility requirements for this future capacity growth. So we're not committing to the equipment at this point, but we do have a facility that's been designed to very rapidly allow us to add that in and ramp capacity up. Now that we have a design strategy and we're moving to FEL1, let's watch the next video, which will focus on understanding the cost impact, the flexibility, and resolve any design challenges.
Problems with uncertainty also extend into the design phase. Now that we've determined what type of biotech facility to build, we need to understand the potential cost impacts of our manufacturing flexibility needs. For our general purpose facility, we want the building systems to accommodate our future equipment. We don't want the facility to be the limiting factor in our operations. This may require increasing the bay spacing and raising the building height. Somehow, we need to evaluate the additional cost of this flexibility versus the value it could bring later. Using the flexibility cost optimization tool, we compared various future scenarios and identified the likely cost impacts to each building system according to the ASTM uniformat. Uniformat is a standard classification system for grouping building elements such as substructure, superstructure, and shell. The tool indicated a small cost premium in the superstructure of our biotech building, which we determined would be less than the cost of making more significant renovations at a later date. How did the tool help us evaluate this cost impact?
Good morning. My name is Rob Brown, Faithful+Gould Pharmaceutical Lead. As a project management and project controls organization, we come across flexibility and what-if scenarios on a regular basis. This could prove very frustrating for our estimating teams, who in many cases can be estimating room by room and area by area. So the opportunity to work with the CII was exciting for me personally. Today I'm going to talk about a tool that we have developed that will assist early decision making and afford some cost predictability for your projects in the early stages. Manufacturing equipment and processes have an impact on the physical facility design. And to meet changing demands, technology is constantly evolving to make the process more capable, efficient, and flexible. So what does this mean? In practice, this means that manufacturing processes are no longer restricted to producing a single product and must therefore adapt to multiple products and demands. Our research found that the industry has looked at flexibility in equipment and process for many years. They have even defined this in textbooks. However, despite this understanding, some physical changes to the facility are generally required for that flexibility to fully materialize. And our research focused on translating that flexibility to the facility and infrastructure. Again, for the estimating teams, we need a simple tool to help owners quickly understand the cost implications of manufacturing flexibility. So to address these challenges, our team developed a tool whereby owners could input manufacturing flexibility scenarios and receive relative cost impacts for single and combined scenarios in a dynamic dashboard. Within this tool, we evaluate how each building system is impacted by using the standard uniformat estimating classification system. So the scale of change to a facility can vary significantly depending on manufacturing applications. Our team applied manufacturing standards to define flexibility. Some of these include machine, process, and product, are generally contained within the equipment themselves and therefore have minimal impact on a physical facility. However, volume, expansion, and operations flexibility can have significant potential to influence building design and therefore costs. So, for example, expansion flexibility may be needed in the future to meet increased production demands, resulting in additional pieces of machinery being added, in our case, the harvesters. This may require additional building footprint and services. Our tool uses a uniform estimate and classification system to allow the user to develop a conceptual cost model for the dedicated facility prior to any flexibility considerations. So how is this done? There are several steps in using this tool. Step 1 is preparing the cost estimate for the dedicated facility option, to which then flexibility scenarios are then compared. Step 2, we can then consider and conduct assessments of how moderate or severe the requirements are to key flexibility. Then the user inputs that information into the tool so that any premiums can be compared to the dedicated facility. Our experience shows that this is best carried out in a facilitated project team environment. Step 3, review of the results. The results are presented in a dashboard summary of overall cost impacts on building systems. The dashboard is interactive and allows for detailed examination of multiple flexibility scenarios. In the following slides, we're going to walk you through how to use the tool for our new biotech facility. So the facility information is made up of 2 key components. 1, basic facility data, and 2, the high-level cost estimate. By applying some basic industrial engineering facility data, we get an understanding of the flexibility in systems that may be achievable. And by using the uniform cost breakdown structure, we can develop a dedicated facility conceptual cost model. And you can see the results of that input here. As we are performing the flexibility assessment early in FEL1, we apply high-level square foot benchmark cost values to our estimate. We then consider which types of manufacturing flexibility may incur within the facility. The user team applies the appropriate flexibility scenario to each of the weighted categorization ranges to arrive at the cost impacts. In our biotech facility, the owner wishes to have expansion flexibility for 2 additional pieces of equipment, and in this case, it's our harvesters. The user team then proceeds to choose the impact of flexibility on each uniform system for the expansion scenario. And these impacts are categorized and weighted as no impact, weak, moderate, strong, and very strong. So the next step, we can now dynamically consider how each type of manufacturing flexibility may result in premium costs. This slide simply illustrates a dynamic dashboard within our tool, allowing owners and project teams to look at high-level cost impacts of the multiple scenarios. As I previously mentioned, creating room-by-room estimates for owners' change can drive our estimating teams crazy. So finally, we now have a tool to dynamically show owners how flexibility can impact their costs. Now that we have this information, we can now move on to the detailed design stage. I'm now going to hand over to my colleague Gil, who will demonstrate our next tool, which provides additional help to the design and cost estimating teams on the next stage of the project. Thank you.
As we continue with facility development, there are often conflicting design requirements. For our biotech facility, we need strict environmental controls. Regulations require specific relative humidity, room temperature, room pressure, and limited airborne particulates. Large and complex HVAC systems are required to achieve this level of control. Our constrained site prevents us from locating these systems externally, but we also can't give up floor space inside the facility. How can we achieve both of these objectives? Using the flexibility idea generator, we were able to consider innovative design ideas that weren't immediately obvious. Of these ideas, our designers decided that raising the HVAC systems to the mezzanine level and using prefabricated ductwork modules not only preserved valuable floor space, but also provided easy access to our other utilities. How did the tool help us make this decision?
Good morning. I'm Gül Kramer, an industrial engineer and a professor from Iowa State University. But allow me to first follow Evan's lead and ask, how many industrial engineers are in the room? May I see the hands, please? Thank you. We are 2, not quite 3. As my colleague there will know, in general, we focus on the processes in the buildings, and we engineer the best human-machine combination to achieve the productivity levels that we would like to see. But as part of this team, I had to go out of my comfort level and think about the flexibility in the building while we are trying to achieve manufacturing flexibility for our processes. Also, as engineers, we focus on solving problems, handling contradictions, and in many of these cases, what happens is that contradicting issues create schedule overruns or additional cost. So how are we going to handle this? In fact, when you're looking at the design as a major step in building projects, this becomes even more important, handling contradictions. But when you're thinking about a flexible facility that is also going to be around for some time, long life cycle, as you say it, it becomes even a bigger challenge. As Rob also was talking about, scale of change that the manufacturing flexibility requires in a building may be different, and it can change based on the type of the flexibility that you would like to include in your design. Whereas when you're including product and process flexibility, the changes may be contained within the equipment with limited impact to the facility. When you're thinking about the demand or routing flexibility, the changes expected will need to be incorporated in the flexibility, in the facility. How are we going to put all of these things in one place? And moreover, how are we going to do this at a good cost? This is, in fact, what we want to do with this tool. For this, we introduce Flexibility Idea Generator. Whatever you do, don't call it FIG, okay? Flexibility Idea Generator. What we have done with this tool is that we have used a proven tool, TRIZ, named Theory of Inventive Problem Solving, and we have customized it for your industry using the patents that have been analyzed over a long time period, but also we coupled all of that with the case studies that we have conducted as a team. In using this tool, the logic is that you pare down the contradictions that you're dealing with, and then you feed them into this tool, which I will show you momentarily. But put yourself in the shoes of the team members that you're working with, where they are under pressure dealing with these contradictions. And the moment is where you're frustrated, you don't even know where to start. So this is the tool where you want to use for those settings. In fact, thinking about those contradictions, you want to be identifying those flexibility characteristics that you want to resolve, especially when they seem to be challenging or contradicting each other. For example, in the biotech facility example that we have heard from my colleagues that we want to incorporate the demand variability. Which means we want to be able to produce, with the same cost efficiency at a lower level of demand versus a higher level of demand. But what we don't want to do is use extra open floor space that we don't want to lose. So how are we going to get this thing done? Given those two contradictions, what we are going to have is we are going to take you to the user interface of our tool. You're going to be inputting those contradictions. And first is the feature to improve, and the second one is feature to maintain. In our case, demand variability and floor space availability is the pair of contradictions that we are working with. And what happens is that after those are input to the tool will give you visuals and explanations of what others have done in their examples, in their proven solutions from around the world. Think about this tool as a repository where using the structured retrieval of the examples, you will be able to access those. In the example that we have been working on, again, the contradiction pair is demand variability and while trying not to reduce the open floor space. The tool is returning two different examples over here. One of them is using mezzanine, and the second one is using roof or other interstitial spaces within the building for utilities or other whatever that you want to build in the flexible facility. In the example that we have, the flexibility solution implemented in the facility design is to utilize the mezzanine to house the support equipment and utilities, rather than using the premium floor space that you have. As I said earlier, though, what you want to do is that you want to be able to use this tool not only as a way to get you out of that frustrated point where you don't know how to solve this particular contradiction, but also expand on it as a repository as you build, as you design additional flexible facilities. Now, Evan will summarize.
Thank you very much. Throughout this research, we determined that the future of manufacturing is flexibility. Dedicated facilities which do not offer the ability to accommodate change over time should no longer be the only designs that you're looking at, that you're working on. Recognizing the challenge of designing and constructing flexible facilities, our research helps you with your decision-making process. In order to do this, the research promotes early evaluation of flexible facility investments. We identified 3 stages in which to consider flexibility that will add value to your facility. In the first stage, the strategy selection guide focuses on proven strategies to approach flexibility, uses ratings based on specific advantages, not just pros and cons, and documents your decision-making process. In the second stage, we have a cost evaluator tool. Understand what flexibility costs, understand the premium, and drive toward your optimal balance between cost and flexibility. And we have the idea generator to help design challenges from throwing your team off course. With this tool, you'll have access to many proven concepts. With it, you can understand that flexibility does not require design trade-offs. So you have a suite of 3 tools to help quickly understand what facility flexibility can do for you, your company, and your clients. They provide objective support for decision-making and have the potential to reduce project delivery time while understanding your costs up front. To summarize, due diligence up front. Provide research-driven tools that are ready to use. Provide objective, data-driven results, hard facts and figures to back up your decision-making. Protect your project schedule. Increase due diligence up front, coupled with objective results, will keep your design effort moving forward. More progress, less circling back. Speed to market. All of the above are focused on moving the design process forward, supporting the speed to market that your business is looking for. So up here are 4, but we represent a much larger team. We wanted to thank them very much, and thank you very much. We have 3 minutes and 42 seconds.
All right, let's do some questions for you guys. We got a few here for you. So the first one is, have these tools been proven useful for making decisions around repurposing existing facilities in addition to the new facilities?
They have not, at least I've not had an opportunity to do that yet. We have been using them for new facilities, and while the tools have just recently become available in the last couple of months, we haven't had a chance to run through all the scenarios. I will say for a new facility, I do have a project I'm working on right now that the tool wasn't ready when we were probably at that decision point, but we have gone back and used the tool to kind of validate, did it direct us in the right decision, and it did. So I can say for at least that. But for modification of existing facilities, not had an opportunity to do that yet.
So if I can add,
Sure.
That's a great concept because the idea behind flexibility is to repurpose a building. So this tool can absolutely be used for that. It's just a matter of working through the details.
Okay, that makes sense. Thank you. And what about the use of or applicability of this tool for other sectors besides just manufacturing?
There's no reason why it can't be. We focused on the biotech solution because a lot of people in the room with us during development were from the biopharma world. But there's no reason why this can't be adapted. The Uniformat financial codes will work for multiple sectors, so we hope that it will be.
Okay.
Yeah, just to add that, because we did have some team members that weren't necessarily in pharma, just as an example, even in chemical. It kind of depends on how you look at a facility, but they had similar strategies on, if I'm going to put additional unit operations in a chemical plant, do I size the utilities big enough for future growth or not? So some of these tools can definitely, to Evan's point, be used for those scenario analysis, even if it's not specifically even a facility or different variations of that.
What about equipment maintainability? Here's a question. Does this tool take into account equipment maintainability when offering equipment configurations?
Let me take that. Just to briefly go back to the earlier question, TRIZ, or the flexibility idea generator portion of it, that particular tool has been used in several other industries. In fact, our effort for this project was try and customize it in an effort to bring that advantage that this tool provides to this particular industry. About equipment maintenance and variability and all of that, that's a big aspect. So that's one of the things, as we have discussed in the presentation, that some of the flexibility can be handled at the machine level with additional investment, but there are certain things that you just cannot. So in fact, we feel that in its entirety, our tools are providing this transition bit, when is it that you cannot handle it no more at the machine level, and then you need to expand to consider the changes in the building.
The other changes, okay. So one last question, because I think this is interesting. There's others that I'm sure you guys can answer during the break. Very excited to have industrial engineering models and skills applied to capital projects or to the industry in general. Are you seeing new IE grads, industrial engineering grads, getting hired by untraditional IE consumers?
I know the person who should respond to this. In fact, as chair of my department, I am in touch with many of the industrial sectors. And in fact, we support many industries from aerospace. In fact, I'm proud to say construction. In the area that we are in, I visit construction firms in Kansas City region and in Omaha region. And our colleagues, our students, with their expertise in especially in project management and organizational skills, optimization and scheduling, we are in fact, producing qualified graduates to help your industry as well to achieve additional efficiencies and productivity. Yes, we want to be in this industry too. So hopefully next year, there will be more than two.
Very good. Thank you so much for your presentation. Please help me thank them. Congratulations.